Okay, so our next notes are about matter, change, and energy. So you should be taking notes in your notebook for this. If you want to do them in a Google Doc instead, that's fine, and save them into maybe a folder for chemistry in your Google Drive. That would be great. But again, you should be writing something down as you go, so you have something to refer back to later on. So first things first, we do have a couple of rules that are followed when we are changing matter. So the first is the law of conservation of matter. It's also sometimes just called the law of conservation of mass. And this says that matter or mass cannot be created nor destroyed. So if I, for example, start out here with 100 grams of this mercuric oxide, okay, it's a compound made of mercury and oxygen, and I decompose that down into its elements, mercury and oxygen. If I've started with 100 grams of the mercuric oxide, I should end up with products that are equal to 100 grams. Okay, so we cannot create or destroy mass. The second is the law of conservation of energy. And this says that energy cannot be created nor destroyed. And so, we're thinking about the fact that energy can be basically transferred from, one type to another, kinetic to potential, potential to kinetic, as you can see in the tree, or we can have stars produce nuclear energy through nuclear fusion and emit that energy, which then goes into, plants and all kinds of other things. We can have chemical energy too. And so that's what we're really going to focus on here is chemical energy. And so you guys take in chemical energy through the carbohydrates, fats, and other things that you eat, and that goes into, your body to run all the processes that help you live. Your body turns it into ATP, and that's how your metabolism works, and you also then give it off to your surroundings then eventually as heat. So there is a little footnote to this. These changes are for our regular chemical reactions that follow this. When we have nuclear changes, they don't follow these rules. And so nuclear changes are things like fission and fusion. Okay, so fission, where we are splitting apart the nucleus of an atom. And we get a whole bunch of energy released, and fusion, where we are basically cramming two nuclei together to make a bigger nucleus, and then we get a lot of energy out. And so, fission is what's happening in like a nuclear power plant. Fusion is what's happening in the sun. And so these changes follow the equation E equals mc squared that Einstein came up with. And that means that energy is equal to mass times the speed of light squared. And so we can take a tiny change in mass and it results in a huge amount of energy being produced. So we really want to focus on changes that matter makes. And there are two types of changes. There are physical changes, and these are changes in matter from one form to another without a change in chemical composition. So for example, like our ice cube melting there. And the second is a chemical change, or a chemical reaction is another name for it. And this is a change that occurs when one or more substances change into an entirely new substance with different chemical composition and properties. So when I light wood on fire, I end up with a totally different substance in the end with totally different properties. It turns into ash, it's a different color, things like that. So those are our two types of changes that we have. So let's delve into physical changes more. Physical changes occur when we have a change in size and or shape. So you can see they're cutting a piece of paper there. It's still paper, it's just changing its size. We have someone sanding something there. So again, it's just changing the shape of that. Another example would be when we're making a mixture. So we can see some food dye, food coloring going into the water there and starting to mix around. Erosion is another example you can see around you, where that's just a physical change. It's just wearing something away. The particles themselves are not changed. The chemical identity of them is not changed at all. It is the same chemical substance. Also with physical changes, substances that have been mixed together can be separated by physical means. And so a physical change would be separating those mixtures. So for example, we can filter a mixture. So you can see in the upper right there, we filter our coffee so that we're not just drinking the coffee grounds. But we also do this in the lab, and we use filter paper. We keep the solids in the filter paper, and the filtrate, that's what goes through, that's the liquid part that goes through the filter paper, drips out to the bottom. We can distill a mixture of liquids. So liquids will have, again, unique boiling points, and so we can distill and separate them based on those boiling points. So you can see kind of the two setups there, an animated setup and an actual setup there. Well, it might be slightly animated, but essentially we're heating something, we're boiling it, and one thing will boil off before the other. Evaporation is very much the same way. You're separating things based on the difference in boiling point. So if I had a mixture of water and salt, I could evaporate away the water and I would just be left with the salt. The other way that we can separate mixtures is by really just like manually picking them apart. So my kids do this all the time. Let's say we have that bowl of trail mix there. You can bet that they're only going to leave the raisins for me, and that the M&Ms will all be gone. Because that's kind of how they work. They're going to pick the things they like out, first, and then go from there. So usually picking things apart manually is not the way that we do it really in chemistry, because the things that we're working with, I can't really pick apart individual atoms easily, without some super expensive and specialized equipment. Okay. So let's talk about last couple types of physical changes then. These are really phase changes. So when we have a phase or state of matter change, like, we talked about melting or freezing or boiling, that's really the same particles, but they are being arranged differently. So that ice cube there, whether it's liquid or it's solid, it's still water particles. Whether that is liquid water in the pan or steam above the pan, it is still water. And so despite the fact that it's gone through the phase change, it is still something that is the same chemical substance. In general, physical changes are easily reversible using just a physical change. So I can pretty easily refreeze that ice cube to get it back to its solid form after it's melted. I can recondense the water to get it back to its liquid form after it has boiled off. So let's talk about chemical changes here. Chemical changes are when a new substance is formed, and the particles of the substance are changed in some way to make something new. And so you can see in the animation at the top there, we have really two different chemical substances. We're transferring that green atom to kind of the blue and white ones, and the yellow atom is separated off of it. And so we can't necessarily see things at the atomic level. So we're looking for evidence on a large scale or on the macro scale to know that a chemical change has occurred. And so there's some evidence that we can always look for. So one piece of evidence is that light is produced. Oh, I should actually say this is actually burning of magnesium. And so it's just a little ribbon of magnesium. They used to use these in like flash bulbs for cameras back in the day. To get something to flash, it wasn't just an electrical signal run through there. It was actually a little chemical reaction that occurred. So they would use magnesium for that because it was a nice bright white light that it produced. They also use magnesium in fireworks because of that bright white light that it produces. And so again, production of light from a chemical reaction indicates that a chemical reaction has occurred. Also, we can see a change in temperature. That's telling us that some sort of energy change has occurred. And so we can have two types of things happen. We can have either an exothermic reaction where heat leaves the object so that it feels warmer, or an endothermic reaction where heat is absorbed so it feels cooler. Okay, so an exothermic reaction, again, heat is leaving, think of it like an exit. heat is exiting that system is something like we see with a thermometer over there on the right-hand side. This is what happens when we mix together ammonia and sulfuric acid. You can see that our temperature goes way up because we're actually getting a bunch of heat being released by that reaction. An endothermic reaction, endo, we have heat going in, so it's going to feel cold to us. If we're touching it, it feels cold to us because it's absorbing heat from the surroundings. Is something like we see there in the yellow. And so when we mix together these two chemicals, we actually can see and watch kind of the temperature change with the color change there. We can see that it's getting colder and colder. This one will actually get so cold that you can put a little water underneath it and you could freeze it to the tabletop, for example. The most common ways that we use endothermic reactions are when we're in the kitchen. So we heat up things, cupcakes, cakes rising, for example. That's an endothermic reaction that we do that's got a very tasty result. Next, we can also have gas bubbles being produced. And it could be a gas or it could be bubbles. It kind of depends on how you are seeing it. And so we see two examples of that over on the side there. We've got on the bottom two different things. We've got iron reacting with hydrochloric acid, and we've got zinc reacting with hydrochloric acid, but they're producing these little bubbles of gas, the hydrogen gas, when they react, and that's what you're seeing coming off of there. Above that is a reaction that we actually usually do in the springtime. So we had just done it before we closed last year. But we have copper reacting with nitric acid there, and it produces this brown gas, NO2. And so we can see that up above the reaction. It's actually also a pretty exothermic reaction there, but so you see it bubbling up from that. But in general, rule of thumb, if you can see a gas because it's got a color like that, it's poisonous. So this one definitely is poisonous and is one of the big components to smog that is really a problem in many major cities. The other thing that we can have is the formation of a solid. When we mix together two solutions, we can get a solid formed, and we call that a precipitate. So a precipitate, again, are solid particles that will settle out to the bottom of our solution. And so we can see a couple of examples. So you can see the far left, we have precipitate there of lead iodide. It's actually the same thing in the little GIF that we have there. It's just you get a different look there. It's a little more crystalline looking. You can see with the formation in that one. But also the other picture then shows us a whole bunch of different types of precipitates that we can get. And so, precipitates can be any different color, but the thing that we're looking for is that they're actually cloudy. So I can't just see clearly through them. I get this cloudy substance that over time can settle out to the bottom. Last, we have that our substances, second to last, I should say, our substances can't really be changed back to their original form through just a phase change. So again, these are chemical changes. I can't just freeze something and get it back to its previous state. I can't easily reverse these chemical changes that are occurring. And the last one, and we have a question mark next to it, the last one is color change. And sometimes we can use color change. It works quite well to tell that something has happened, but not always. And so we have a couple different pictures here or GIFs here to have you consider. If you look at the one on the top, as they shake that, it changes color. They're not adding anything to it, but they are shaking it and getting this color change. The one below that, they're adding kind of a pink solution to a colorless solution, and they're ending up getting something that first is, pink a little bit, and then it's blue, and then it eventually fades even more. And so we're getting some color change there, and it's different than the two solutions that we started with. The other two pictures then on the lower left have drops of the either blue, green, or red solution being dropped into glasses of colorless solution. And so, when we're thinking about which ones of these color changes would be our evidence for a chemical change, we're thinking about the ones here on the right being yes, chemical changes, because again, we're getting something different than the original things that we put in there. In the top one, it's actually changing color because it's reacting with some of the gas that's in that container. In the next one, it's reacting, and we're getting not just a pink and a colorless thing, but we're getting two different things, different colored things, or a different colored solution as a result. But in the lower left, we just really have food coloring being added to water. And so when I'm going to get blue water when I add blue food coloring to it. That color change does not mean that I actually have a chemical reaction that has happened. So that is, again, a no for those over there. If it's not changing the color, if it's staying the color of one of the things that I mixed in, then it's not necessarily evidence of a chemical change because of the color change. So again, the changes in matter can either be physical changes. Those are easily reversed by a physical change. And it's not a change in actually the chemical unit, kind of whether it's an atom or a molecule that's making that up. Whereas a chemical change, also called a chemical reaction, we're forming something new, and we have those five pieces of evidence that we look for: a change in temperature, light being produced, gas being produced, solid being produced, and potentially color change, and these are not easily reversed. So there's a little summary of our different types of change that matter can make. Please make sure that you record some notes in your notebook.